Assalamu alaikum warahmatullahi wabarakatuh. Today, Monday, the 24th of June 2024, we are going to see a topic in mathematics which is differentiation. And differentiation is a concept in calculus that deals with how things change, or more specifically, it is called the instantaneous rate of change. You can just see it here. So when we talk of derivative, we just mean calculating the instantaneous rate of change of a function. So to really understand it, let us begin by seeing the equation of a straight line. Okay, now on this slide, on this other side, so you can see I have just drawn a straight line, that is the line on the xy plane. And this line, I want to know the slope. So to calculate the slope, we need 2 points on the line, at least 2. So if we have 2 points on the line, and I've called this point B, and down here, we come here, we can call it x2, and down here, we can call it x1. If we extrapolate to the y-axis, I can call this one y1. Extrapolate to the y-axis, I can call this y2. Y2 is corresponding to x2 and x1 is corresponding to y1. Now to calculate our slope is equal to the change on the vertical axis or on the change in the horizontal axis. And our vertical axis, the change is simply referring, if I make like this, is simply referring this distance portion here or this portion here. That is what we just call the change, this portion here. Okay, so that is what we call the change, the distance between y2 and y1. That's what we call the change. And the distance between x2 and x1 is what we call the change on this axis as well. So that is what we are going to find. And to find it, you simply say y2 minus y1 will give us the difference here, and x2 minus x1 will give us the other difference here. So this one will be same as y2 minus y1 all on x2 minus x1. So this is our slope. So now when we talk of derivatives or differentiation, we are saying now, okay, what you have been given a curve that looks like this one that you are seeing here, that the curve is the curve y, this is the curve y equals to f of x. And in same again, you can still find the change. So let us say if we consider 2 points on this line, we consider a point here b, and we consider a point here a. And let us say this point has x coordinate x, and the other point has a coordinate x plus h. That is, we increase from x to this point here. Let us say we add h, and the point here will simply be what? F of x. This is the point here, since we are having the curve y equals to f of x. So when x is x here, as we are having, then this will be equals to y of f of x. And similarly, the other point up there will be y equals to, we'll be having f of x plus h. F of x plus h. So f of x plus h. So now those are the points. And similarly again, we can still calculate our slope. Our slope, which will now be equals to, our slope will still be equals to what? The slope will still be equal to f of x plus h minus f of x. That is, I'm talking for the of this one is just like our y2 and this one is just like our y1. And we divide all that by x plus h minus x. That is our x2 minus x1, something like that. And now what do you notice here? You notice that this x and this x cancels out. Okay, this x, I mean this one and this one, they cancel out. Now if this ones cancel out, you then left with what? You just left with what? F of x plus h minus f of x all on h. Okay, and this is now the formula to calculate the slope of a function. But now this one, now is it constant? No. The difference of the point, it is, look at the line. If you draw the line like this, it will be this line, but we are calculating for a curve like this. So if we take limit at h go to 0, that is, if h go to 0, that is our increase in such a way that this point should be on top of one another, or they should be very very close to one another. B should be nearer to it, that is, we make h to go to 0. So if we take limit as h, if we take limit as h goes to 0 of f of x plus h minus f of x all on h, then we can now say that the slope will now be constant. And this is what mathematicians call f prime of x, or some people just call it, dy and dx, dy on gx. Okay, now if you have this, you now continue. Let us put back what I wrote, dy on dx, something like that. And now if you try to find the derivative of each function, this is simply the approach you are going to use. Okay, though there are other techniques that will help you to find the derivative of a function. Let us say example. We are having f of x to be equals to x squared, and to find the derivative we'll just simply now be having our f of x is equals to x squared. So we'll now be having limit our f prime will be f prime of x squared. Our f prime of x will be equals to limit as h tends to 0 of f of x plus h minus x minus f of x all on h. But now our f of x is simply what? X squared. So we'll now be having x plus h, we'll be having x plus h all on squared minus x squared all on h, limit as h tends to 0. And if you expand this bracket, this one just simply means x plus h into x plus h minus x squared on h. And if you open these brackets, you multiply this, so you FOIL it, you take x, you multiply by this, you're gonna get x squared, and they take x, you multiply by h, you're gonna xh. They take h, you multiply by x, you get xh again, and then you get h squared, and you get minus x squared, which is hanging over there. Now we get here h on the bottom. And if you have that, all of this is limit at s goes to 0. And you see this x squared cancels with this other x squared, this x squared and this one, they cancel out. Okay, and if they cancel out, you just simply now be having x plus h will give us 2x plus h, so we'll be having 2xh plus h squared all on h. And now if you put 0 here, this will be undefined, so let us go ahead and factor out h up there. So all of this is limit as h goes to 0. And what are you having here? You're having now h into 2x plus h all on h. And now this, I've just factored, you can multiply it and have it back. If you multiply h times 2x will give you 2xh, h times h will give you h squared, okay. And now if it's this h cancels, and you now be getting, you now be left with limit as h goes to 0 of x 2x plus h. If you substitute now h goes to 0, you just simply get 2x plus 0, which is equal to 2x. So indeed we have found that our f prime of x is equal to 2x, that the derivative of f of x is equal to 2x. And now what you have to know again with this is simply you are just getting the slope of a line, that is the slope of that curve. And now if you can find, what if we are asked to find the slope at the point 2, 4? Well, on that our function y equals to f of x equals to x squared, you know that the graph is something like this: 0 square 0, 1 square 2 square, something like that, negative 1 square. The graph will be something like this. This is y and this is x. This is y, f of x, or y equals to x squared. This is the graph. And now if you go ahead and find the derivative, let us say the prime at the point 2, 4, somewhere here, and now your f prime of x plus equals to 2x, and now at 2x here we'll be having the coordinate 2. So if you put x here, 2, we'll be having 2 into 2, which is equals to 4. I can go ahead and find the equation of the tangent, right? The tangent line, this tangent line, this, you know, the slope. And you know that equation of a straight line is equal to y minus y1 equals to m into x minus x1 is equals to m into x minus x1. And this will be indeed equals to y minus our y1, or simply the point that we are having here, 4. We'll be having y minus 4 equals to m, which is the slope, which will be 4 into x minus our x1, which is simply 2. I can arrange it neatly. Y to be equals to 4x minus 8 plus 4. I've simply taken this negative 4, I've put it here to be positive. Okay, I just simply get y equals to 4x minus 4. So at this point 2, 4, the tangent line that passes at this point, the slope, the equation of the line is simply this, and the slope of that line is equals to 4. That is what we have found here. So this is all about the introduction into derivatives. And now, where do we, what the next thing will come to our mind is applications. Where do we apply this concept of derivatives? Well, in physics, it is, let me start with physics. In physics, if you have displacement, let us say displacement is equals to s of t, that is s, that is displacement as a function of time, then you know that velocity will be equals to s prime of t, that is the first derivative of displacement, and this will be equals to the velocity as a function of time. And now acceleration is equals to the second derivative of time, or which is equals to the first derivative of velocity. That is, you still differentiate this equation. So this is how we can find displacement. This is how we can find velocity and acceleration from displacement, and we can go back by applying another theory called integration. Okay, now this is the some of the applications in physics. What about chemistry? Well, in chemistry, okay, so this is now what I've done. So in chemistry, the graph of concentration against time looks like this. That is, this is the curve. This one in green is what is a reactant curve, and the one like this is the product curve. That is, the rate of reaction can also be modeled by calculating the slopes of the concentration with respect to time for the product and the reactant. So differentiation has a lot of applications in engineering fields in general, in sciences as well. So thanks you for watching. Make sure you like and subscribe to African Center for Excellence YouTube channel to be a member, and you can also share to your friends. And I wish you the best. Have a great day. Thanks for watching this video.